I will talk to you about dimensional modeling, star schema, and assignment 3 today. This is part of chapter 8. Chapter 8. Data warehouse is chapter 8. So this is part of chapter 8, and this is about how to design a data warehouse. So this lecture is more technical than so far, and we will talk about how to design a data warehouse today. You should know how to design a data warehouse from scratch, okay? And so we will talk about dimensional modeling, data warehouse design. The data warehouse design is based on dimensional modeling. Dimensional modeling, why? Because all of you know by now that data warehouse contains huge volume of data, and dimensional modeling supports high volume query access. And dimensional modeling is implemented via star schema. So we would learn how to design a data warehouse that is based on dimensional modeling, which is implemented via star schema. Okay, a star schema consists of one central fact table surrounded by several dimension tables. The fact table, remember, so dimensional modeling is used for or is implemented via star schema, and star schema has one central fact table which is surrounded by several dimension tables. What is a fact table? A fact table contains always quantitative data, okay, about a business. It contains quantitative data about a business, and it contains a large number of rows. Fact table is a large table, is a huge table. It contains a large number of rows that correspond to observed business or facts. Okay, so fact tables contain quantitative data about a business, and it contains information that are queried often. What would be some examples of quantitative data? Revenue, sales, profit, cost of goods sold, etc. Then what are dimension tables? Dimension tables are smaller tables, and they hold descriptive data. Fact table, quantitative data. Dimension table, descriptive data that reflects the dimension of a business. Example would be product, region, location, customer, time. They are descriptive data. What are the different types of product? What are some of the attributes of a customer? Which region? Are you talking about southern region, western region, eastern region? Time, is it weekly, monthly, yearly? So these are all descriptive dimensions of a business. Okay. Now I will talk to you about keys. When you have a table, you have to have a key. Okay. When you have a table, you have to have a key. I will talk to you about three types of keys: primary keys, foreign keys, and composite primary keys. MIS majors, they all learn about these keys in the very first MIS class they take. Okay, but non-MIS people, and most of you are non-MIS, so you need to know what are keys before you can design a data warehouse. Okay, it's very important that you understand how to identify a key. This is hands-on. You have to do it for your assignment 3. So you need to know how to identify a key. I'm trying my best to explain how to identify a key with examples. Please go over this. After this, if you think you are not sure, if you are not understanding properly, please feel free to call me, drop by, or write me an email. But please make sure that you understand how to identify keys. Otherwise, you can never design a data warehouse. Okay. Now I give you an example table. This is a, look at the table. It is a student table. It has student ID, student name, and student address. What is it? Is it a fact table? It has no quantitative data, so it's not a fact table. What is it? It's a dimension table because it has descriptive data. I give you this table. I give you, so the columns are ID, name, and address. And I give you the data. Okay. Look at the data carefully. If I ask you, okay, say for example, take my case. I teach hundreds of students every semester. I may have 5 JSON in my classes. So if one JSON comes to me and tells me what is my grade so far in the class, I cannot pull his record with his name JSON because that would give me 5 rows of data. There are 5 JSONs. Same thing, address. It's always, it can be, there can be situations when several students would share the same apartment. Okay, so that would not be unique. I'm looking for something unique which is not repeated. In this case, student ID, your L number in Lamar is unique. Okay, so a column of a table, there are 3 columns in this table: student ID, student name, and student address. That uniquely identifies each row of the table is called a primary key. So in this case, since I can have 5 JSONs in my class, several students can share an apartment, student ID is my only unique column. Okay, because student ID is the only thing that is unique about the student, because no 2 students would share the same ID. So student ID is my primary key. So now you know how to identify a primary key. Primary key is basically a column of a table where each row is unique. So no row would repeat itself. Look at the second table. I have, this is a ordered product table. Okay, I have product ID, order ID, and I have the quantity. Product ID is P1, P1, P2, P2. Product ID has repeated itself. In this table, it has repeated itself. I have 2 times P1, I have 2 times P2. So, if it is not unique, I cannot make it a primary key in a table. Look at order ID. O1, O2, O1, O3. O1 has repeated itself. So, if a row repeats itself, I cannot make it a primary key. Quantity, think about a fast food restaurant. You can go and ask for 2 sandwiches, 2 chicken sandwiches. I can also ask for 2 chicken sandwiches. So quantity can never be unique. Several people can ask for the same amount of different items. So in this table, if I have to have a primary key, quantity can never be the primary key, as you understand that several people can ask for the same amount of items. I would think product ID can be a primary key, but in this particular table, it can't because it has repeat values. Order ID cannot also be a primary key because O1 has repeated itself. However, if I now try combining product ID and order ID, see what happens. P1O1, second line P1O2, third line P2O1, fourth line P2O3. The combination is unique. So, when I have more than 1 columns combined to have the rows unique, that's called a composite primary key. So in this table, I do not have a primary key as such because product ID is not unique, order ID is not unique, but I do have product ID plus order ID together to be unique, which is a composite primary key. So when more than one column becomes a primary key, it is called a composite primary key. Now we will learn what is a foreign key. Okay, another example of a composite primary key. I have student ID, course ID and grade. Grade, several students can make an A in class or B in class, so grade can never be unique. Look at this example. In this example, 13 student ID 13 is repeated twice. Course ID 3310, misy 3310 is repeated twice. So student ID cannot be a primary key. Course ID cannot be a primary key. But student ID plus course ID 13 3310, 17 3310 and 13 4350 each is unique. So in this is another example of a composite primary key, which is student ID plus course ID. Now you will learn something which is very, very important. That is called a foreign key. If you do not know foreign key, you don't know how to design a data warehouse. Okay, so it's very important that you understand what is a foreign key. Okay. First is, if the primary key of one table shows up on a second table, it becomes the foreign key in the second table. Example, I have two tables. I have customer table and I have order table. Customer table has columns customer number, customer name, customer address and customer phone. What would be the primary key in the customer table? Name, address, phone can repeat, but number is always unique. So customer number is the primary key of the customer table. Look at the order table, the second table now. It has order number, order date, order time and customer number. Okay, so in the order table, order number is unique, so order number will be the primary key. In the order table, order number will uniquely identify each order. You placed order number 1, I placed order number 2. Your order number and my order number can never be the same. So order number is unique. It is the primary key of the order table. But look at customer number in the order table. Customer number has shown up in the order table, which is actually a primary key of the customer table. Okay, so as per definition, if the primary key of customer table shows up on order table, it becomes a foreign key in the order table. So if the primary key of one table shows up on a second table, it becomes the foreign key in that second table. So customer number is the foreign key in the order table. What are foreign keys for? Foreign keys are used for joining tables. In database or data warehouses, you need to query information. You cannot have tables which are dangling, which are just not connected. You have to connect all the tables. So in order to join the tables, the rule is that you join from the primary to the foreign. So customer number, which is the primary key of the customer table, will be joined to the customer number, which is the foreign key of the order table. Okay, now the primary key and the foreign key, when you join them, they have a relationship between them. What is that relationship? The relationship is one to many. So one customer, it's always the many is always on the foreign key side. So the relationship is one to many from customer to order. So one to many means one customer can place many orders, but one order is placed by one and only one customer. That means I can place multiple orders, but one particular order would belong to me and only me. Order number 1 cannot be yours and mine. It has to be only one person's. Okay, so this is the business relationship, business association between tables. So once again, if the primary key of one table shows up on another table, it becomes a foreign key in that table. Foreign keys are used for joining tables. You go from the primary to the foreign, and on the primary to the foreign, the relationship is always one to many. So many on the foreign key side. Now, How to draw a star schema? I gave you 4 tables. Okay. In these 4 tables, the quantitative information, remember the quantitative information will always go to the fact table. So our fact table, I call the fact table sales. So it has all the quantitative information, sales, profit and revenue. Then the dimension tables are product, customer and region. Product table contains product ID, product description. Customer table contains customer ID, customer name. Region table contains the first label, that's the name of the tables, okay, like product, customer, sales and region. The items below the table names are the item and the columns in the table, okay. So product ID and product description. The product table has these 2 columns. Customer table has 2 columns, customer ID and customer name. Region has 4 columns, region ID, country, state and city. Now notice that each of the dimension table has a primary key. Product ID is the primary key of the product table. Customer ID is the primary key of the customer table. Region ID is the primary key of the region table. Okay. Now notice very carefully. In the fact table, first you put down all the quantitative data, which is sales, profit and revenue. Then you also add the primary keys of the dimension tables, which become the foreign key in the fact table. So I would add product ID, region ID and customer ID. They are primary keys of the dimension table, and so they would become foreign keys in the fact table. And then I have to join from the primary to the foreign, product ID to product ID, one to many, customer ID to customer ID, one to many, and region ID to region ID, one to many. Okay. So always from the primary to the foreign, many on the foreign key side. Once again, if I ask you to draw a star schema, you have to put the descriptive data in dimension tables, you have to put the quantitative data in the fact table, and then you have to take the primary keys of the dimension tables and also put them in the fact table. And then you have to join the primary to the foreign keys. So product to product ID, customer ID to customer ID, region ID to region ID, and always one to many. Many is on the foreign key side. So this is about designing a data warehouse. Now I will go over assignment 3. Okay, assignment 3 is on Microsoft Access. Microsoft Access is in lab 109. Okay, it's also in the library. You have to use Access to work on this assignment. Okay, I know all misy majors, they all know how to use Access. If you don't know how to use Access, it's not difficult to learn. Okay, maybe I will do desktop capturing and I will put it for you to know how to work on Access. You can also take help from Aaron Townsend. Aaron is our student help. Okay, you can ask me. I will load a video on how to work on Access by using that Camtasia, the desktop capturing software. What you have to do is you have to open Access. You have to create the tables, identify the primary keys and the foreign keys, and you have to join them. Okay, so what is the assignment on? The assignment is due on February 3. It is about information. It's basically designing a data warehouse for a coffee store so that you can analyze the data for a coffee store. You can think of Starbucks. Okay. The coffee store has the following information: product type, and I gave you examples so that you understand what those data items mean. Okay. Now, while you implement the thing in Access, you don't have to put in data. You just have to create blank tables. Okay. Now, I gave you the data just because I would like you to know what the data type means. Like product type, what is meant by product type? For a coffee store, it can be coffee, espresso, herbal tea, tea. Product description can be Colombian, cafe latte, mint, Darjeeling. Product ID can be 1, 2, 3, 4. Product type can be like regular, decaf. Area code gives you store location. State in which the store is located, like Washington, California, Texas, Connecticut. Market, location of the store in markets such as east, west, south. Market size, small or major. Profit, measured in dollars. Margin, measured in dollars. Please note, quantitative data we are talking about. Sales, measured in dollars. Anything measured in dollars is quantitative. Cost of goods sold, measured in dollars. Then budget profit, budget margin, budget sales, budget cost of goods sold. What do I ask you to do? I ask you to create the dimension tables in Access. So you create the several tables in Access. Those are dimension tables, and put the columns in the tables. You don't have to put the rows. Rows, content data, you don't have to put in data. Just create the tables, the dimension tables. Then identify the primary keys in dimension tables. So the dimension tables that you create, you find out what are the primary keys of those tables. Then create the fact table. Fact table, remember, fact table has quantitative data plus the foreign keys, which are the primary keys of the dimension tables. So create the fact table. Then the foreign keys in the fact table. What are the foreign keys in the fact table? Foreign keys in the fact table are the primary keys of the dimension tables. Then create the star schema for the coffee store. How would you create that? You have to join from primary to the foreign. Okay. Primary key of the dimension table to the foreign key of the fact table, you have to join, and you have to also enforce referential integrity. Okay. In Access, you can right click on the joining of the tables and you can enforce referential integrity. And then once you join the primary to the foreign keys, your star schema for the coffee store is ready. And once you put in data, you will be ready to analyze its financial health. Okay. Now, I would ask all of you to go over this video and then to start your assignment early so that you can get enough help while you work on the assignment. Okay. Go over this video again, open your Access, see if you are understanding it. If you are not, I can go over it again. You can come for the class lecture on Thursday. I can go over it again.